always starts from North Pole. So always, rule number 1, must start from your north direction. Okay, yes. Second, you must always turn clockwise. In exam, if you forget what is clockwise, look at your watch. If you are not wearing an analog watch, look at the clock on top. Where is the second hand turning from? So that direction is clockwise. Okay, so turn clockwise. And then third, it must always be represented by a 3-digit notation. Example, 30 degree. In bearings, we will write 030. Okay, if it's 152, then no problem. It is already in 3-digit notation. But what if it's not an exact angle? For example, I calculated it's 23.7 degree. Bearing don't care about the accuracy. These are the 3-digit that they want. But the 0.7 is not counted towards the 3-digit. This one is for your accuracy. So you will still write 023, but with the 0.7 behind. Yes. Assuming I already round off to 1 dp. Okay, so that will be the answer you write. So that 0.7 does not count towards the 3-digit. No, so as if this is the angle that you have, this will be the bearing you write. I wrote this, okay, sorry. Okay, so these are the 3 things you need to take note for bearing. So bearing must always be you standing at a fixed point. So for example, this one, I am standing at Y, right here. So when I stand, I must always look in the north direction. Okay, I'm always standing facing the north direction. And then I turn clockwise to where I want to see. So for instance, I'm at Y. I'm looking at this direction. And then I turn clockwise until I see X. So what is the bearing for this? What is the bearing to see X from Y? 20 degree, right? So you write 020. Okay, just add in your 3-digit notation. Okay, same thing, but now the difference is I am from X now. I am standing here. So again, you need to look at the North Pole direction. That means I'm looking here. North direction, and then I want to turn until I see Y. So I'm looking here, I turn my whole body until I'm facing Y. So this is the bearing that is formed. So I want to find that angle. What you can do is you can always extend this line and you will see an alternate angle here. This is also 20 degree. So what is the 20%? 20 degree. So what is the bearing of Y from X? 200. The 180 plus the tiny 20 here. So 200 degree. So imagine you are standing here facing this direction. You need to turn your whole body until you can see Y. So that is how you move. Imagine you are standing there then turning your whole body. Yes. Okay, because my X is starting from the North Pole, right? So if this is by right the horizontal line. So I need to start turning from here until I see Y. Okay, because 2 North Poles are always parallel to each other. When they are parallel to each other, I have alternate angles. Yeah, so that's why this is 20. This is also 20. Okay, so bearing, you just need to be careful and follow the 3 rules, then confirm can get. Bearing only the part A only of your whole trigo question. Part A. 1 part, by tiny part. So next one is, I'm starting from Y. Oops, that's my eraser. Okay, so again, I'm I'm facing Y. So here facing the North Pole. And then I have to turn until I see Z. So turn until I'm facing Z. Okay, so what is that full angle? 140. So the bearing is just 140. Okay, last one. I am at Z. I am at Z. Okay, now I am at Z, facing the North Pole again. Okay, I need to turn until I see Y. So I turn, my whole body keep turning until I'm facing Y. So you just imagine the clock hand. Where's my, this one. Like you are here, right? And then you turn clockwise until you are pointing at Y. So this whole angle, the red one, it's your bearing. Okay, so imagine you are the clock hand. Turn until you are facing that point. So the angle turn is the bearing. So how to find the angle?
One alternate.
Got alternate angle, right? So if this is 140, then this is also 140.
320.
So it will be 180 plus 140. So 320. Okay, so how can you label the angle if you want to show working? Sometimes when you draw your new North Pole, right? You can label them differently. Like call this N1. Call this N2. Then you will be able to tell me, oh, angle N2ZY is what angle and so on. So you can label your North Pole. Okay, but this is just a practice. Okay, so most importantly is where you are standing. They will always tell you from where. This is where your North Pole is. Okay, your north direction is. You are drawing your North Pole from that point. Then start turning. Okay, so now another question. Boat B is 4 kilometers away from the lighthouse L on a bearing of 320. So looking from here, keep turning until you reach the boat. So this whole thing is 320. That's what the question tells us. Find the bearing of L from B. So now they are saying put your North Pole at B and find what is the bearing. Okay, what is the bearing of L? So start from the North Pole, turn until you see L. Done. So how to find this angle? Okay, find this one first, right? So this one is, so your angle NLB is 360 minus 320, angles at the point. So this is 40 degree. After you know this, how to find the angle on top? Okay, what's the property if I were to ask? Interior angles. So angle N1BL is 180 minus 40. So this is interior angles. Okay, so this one 140. 3-digit notation already, so nothing to change. Okay, next one is the keyword that they are using. Another boat Y is due north of L. When something is due north, it means it is in the north direction of L. So that means this boat L is lying on this line. Okay, you don't know where. No, this boat Y is lying in the north direction of boat L. Okay, and it is in the east direction of B. So this is my North Pole, right? Where is east?
Right side.
So like that, right? North, east, south, west. Well, how do you remember a direction when you were taught younger? Naughty elephant spray water. Okay, can, sure. So due east means it must go in perpendicular to B. So due east means it must be at 90 degree to this point here. So this thing is 90. When it hit another north point, this is also 90. Okay, so the word due east, due north, due south, you know you are seeing a 90 degree somewhere. So once you have a right angle triangle, then you can find the distance ly. That means both y is here. So to find this distance, this is a right angle triangle. You can use Tuakaso, you can use your sine rule, any rule you want, as long as you have enough info.
Adjacent and hypotenuse.
Okay, so this one is hypotenuse adjacent. So I'll use cosine. So cosine 40 degree is Ly over 4. So Ly is 4 cosine 40. Okay, so you give me a 3SF answer. Okay, so the math behind it, the trigo calculation, the sine rule, the cosine rule, is everything you have learned. This is just adding real life component to the question. What's the answer? 3.06. Okay, you see, L is here, right? Then they tell me Y is in the north direction of L. And then my point B is here. So I know North Pole is here. But if it's going east, it is here. Okay, east. So they must, the north and the east must meet at 90 degree. If not, it cannot form that 4 quadrant. So that is why this must be a 90 degree. And your Y must be here. Because this is the overlap. It is due north and due east of B. So it must be there. Y must be there. So that's how you get the right angle triangle. Okay, so when you see these kind of words like due north, due south, you know there must be some right angle triangle somewhere that they are hinting. Okay? So you see the question just added that bearing component. But other than that, the rest are your trigo question. Okay, next one. Two ships, Q and R, are on a bearing of 35 degrees and 115 from port P. So meaning from port P is where I am. So this is my starting point. Okay, and then it says that the Q has a bearing of 35 because of the word respectively. So move to Q, 35 degree. That's what they are telling me. If I turn all the way to R, it's 115 degree. So this whole thing, 115 degree. So indirectly, they are telling you that QPR is, what is angle QPR? 115 take away the 35. So 80 degree. So they are telling you that the angle between the triangle is 80 degree. Then they ask, what is the distance QR? Then you forget about the bearing. Imagine you have this triangle. They want you to find this length. You have 80, you have 500, and you have 900. How would you find this? Cosine rule. Because remember, cosine rule is all 3 sides given, or 2 sides, and the included angle between. So these are the 2 criteria where you use cosine rule. Okay, so in order to find QR, it will be QR square plus the sum of squares of the other 2 sides minus 2 times the product of these 2 lengths followed by cosine 80 degree. So to find QR, just take a square root. And then the answer is your, they say nearest meter. So what's the answer? so tired. What is it? 950. But the 5 feet is 950.6401. Then isn't it 951? Oh, 951. Okay, so QR is 951. Now they say, can you find the bearing of Q from R? So if I put my same north pole at R, okay, and then I want to look at the north direction, turn until I see R. No, turn until I see Q. So turn until I see Q. So I ask myself, what is the angle that will help me find the answer? This one, no problem. I know it's 180 already. This part here, I can also find.
Just parallel lines.
Correct. So this one, if I alternate, this is 115. So this one I know. What I need to find is the blue angle here. So how to find the angle there? How to find the blue angle over there? Sine rule. So this one match with the angle opposite. So sine of the angle QRP over 500 is sine of the angle 80 degree over 950.6401. So cross multiply sine inverse. So they will combine the question together and test you as one chapter. Okay, but actually it's two different chapters. Yes. Because alternate here. There we are. Let me use green.
Are we gonna do the chapter?
Which one? No. Okay, so what's the answer? 3, 2, so big? You check? Why so big? You got inverse or not? Or 31, okay, 31.196 degree. So to find bearing, don't forget your purpose is to find bearing of Q from R. You need to add the 31.196 to the 115 to the 180. So what's the answer? 326.19. So 2. 1 dp. So this is the 3 digit. This is for the accuracy. So this is the bearing I need. Okay, so bearing just like that. North pole clockwise 3 digit notation. Other than that, the rest is sine rule, cosine rule. Okay, nothing new. Okay, nothing new. Or even Tuakaso. So that is our 8.1 is done. Okay, challenge if you are curious about where Recruit Lobang and Recruit Aloysius is going, you can calculate. But let's move on to 8.2. Wow, you feel like Vel throw the notes at Harita's face. Such a strong wind. And then despite all this, somebody can sleep very peacefully. Like the world is not shaking. Yeah, this one is from the Our Boys to
Directly
Men.
next to the wind.
Right, you see this person?
Is it the wind must be nice?
Don't know why.
Oh, he woke up.
You woke up? You know, just a battle just happened in your midst and you got no feeling about it.
Yeah.
Yeah, because a set of notes flew past you. Okay, next one. Yeah, so this one is the 3 digit already followed. This is for accuracy. So the 0.2 doesn't count towards the 3. Yeah. angle of elevation and depression is nothing. You just need to know where you are lying, where you are looking from. Okay? If this is my eye level, if I look up, it is always with respect to my eye level. Whether I lie on the floor or on the helicopter, this is my eye level. So my angle of elevation is always from the horizontal line to how much I look up. So this is the angle of elevation I'm talking about. Depression, same thing. I'm looking horizontally. I look at Raj back, right? I tilt my head down, or I move my eyeball, whatever. So eye level move down. Okay, eye level move down. So my angle of depression is here. Not here, you all will always mistaken it to be here. So it's always with respect to my eye level. So again, eye level look up to the fan, right? So this is my angle of elevation. Eye level look down to the back. So this is my angle of depression. That's all. Okay? So if I look, yes. Okay, last one. Yeah, this one. Not last one. 8.2.
It's just the angle, right?
Imagine you are so small, like a tumbelina. On the floor, you are only like an eyeball height. Here. Okay? So this is as tall as what you are. Okay? You are just there. Assuming I don't know, you lie on the floor. Okay? Then they say find the angle of elevation of the top of the lighthouse that is 120 meters away. So, the important thing is, I don't care logical or not logical, your eyeball is there. So, this is your eye level. Angle of elevation is how much you look up. Yeah, so actually they only want you to find this angle, but they use a beautiful word to...
Do we have to put it in bearings?
No need, it's just angle. So this is the angle of elevation they want you to find. The rest is just tuakaso. Yes. So H, A, O. I have O, I have A, I use tua. So tangent of the angle of elevation is O over A. Correct. So you just need to know where is it. You know where is it, your angle is looking at you. Because in real life we say angle of elevation and depression. If not, they cannot tell what you're talking about. Why are you doing your eye level? What's the answer? Yes, so, okay, if I'm here, next person stand here. My eye level is parallel, it's always horizontal. The angle of depression that he looks down is the same as the angle of elevation. So it is an alternate angle. So it also happens to be your angle of depression.
Depression.
Because depressed must go down. Elevate. What's the opposite? What is the word? Antonym, don't know what. What's that word opposite meaning of elevate?
De-escalation.
Okay, but they say it's depressed, go down. So that's why they use the word. Okay, so looking at this, T represents the top of a vertical cliff. The cliff, we don't need to draw the whole cliff. So two boats, one at A, one at B, same level as the bottom of the cliff. So they are telling you it's a horizontal line basically. And then they say find the angle of depression of A from T. That means you are looking here. Okay, you're looking here. Ravan, look at me. Okay, so horizontal, eye level. I look down until I see A. So this is the angle of depression they want. it is the same as asking you to find this. Because it's an alternate angle. Can you see that? So when they ask you to find this, they're asking you to find this. So how to find this when you have 3 sides given to you? I have all 3 sides of a triangle. Cosine rule. So 58 square, sum of squares of the other 2 sides. Oops, I got degree. Angle TAB. So then you can also memorize the angle formula. So if you shift this entire chunk to the other side, okay, you don't need to show all this. If you can just straight away manipulate, go ahead. I'm just being very, very explicit in the steps. Okay, so I swap the position of these two. I swap them. Okay, then after that, I divide this whole chunk below. Okay, so this is gone. And then I take cosine inverse of the whole expression. So this one I also lazy to recopy. So you cosine inverse the whole answer. So you can skip all the steps you want and straight away write this for me. Visualize the manipulation in your mind. Okay, so what is that angle that you can find? 31.00 02. So we can say it's 31.0. Okay, 1 dp. So that's A's answer. Okay, next I want to find the angle of elevation of T from B. So if my eye level is here, horizontal line of sight, I look up, they want me to find this angle of elevation. So no problem. I want to find the angle. I know this is 58. I need one more side. If I don't have one more side, I cannot find the angle. I can use alternate angle. ATB also can. Okay, so what Shu Huai was saying that if I can go and find this angle, right? If you can go and find the green angle using sine rule or using cosine rule to find that angle, the total of the red and the green one is actually the blue one because they form an alternate angle. Then I don't need to go and find the length. So you can do that. So go and apply cosine rule one more time or use sine rule to find angle, the green angle, and then add to the red one to find blue. It's the same. Okay, alternatively, you can use the big triangle here. Remember I told you all the shortcut, right? If you have the hypotenuse, the base here is 96, cosine 31.02. The height here is 96, sine 31.02. So actually I know this is 96, sine 31.02. So knowing this, I can find my angle. Hypotenuse adjacent opposite with O and H. I can find my angle TBF. So O over H. Yes. Sorry? So remember whenever I told you all before, right? If you have the hypotenuse length. So let's say this is 30 degrees. If you know that this is 5, the base will be 5 cosine 30 and the height will be 5 sine 30. This is a short form. This is a quick shortcut to find the base and the height using hypotenuse. But if you go and use Tuakaso, normally you will also find these two. It's just that this is a quick way. Okay? So, sine inverse this whole thing. What's the answer? The base is the cosine. The top is the sine. Yeah, so it's like a shortcut. But if you do Tuakaso, it will work the same way.
How do you like what if I said
Oh no, they will tell you they are looking up to T. So you must be here, look up to T. So from the horizontal line, look up to T.
but you can also look at
So you must like that, cannot. So same direction as where the
it must
T
be
is.
acute.
Yes. What's the answer for TBF? 58.5. 1 dp. Height of the cliff I found already lah. Yes. This is the height of the cliff. Yes.
Since you say this one is equals to this one, right?
Alternate.
Alternate, right? Then basically I can find this one first, which is this value. Then I plus this one.
So
Then
the
should be
red one
same.
and the green one is the same as this one. Also
Okay,
can.
okay.
Yes.
Oh, this one. Oh, just now the 115, right? What's the point of this?
Of course I want the whole thing, ma. So if this is 180, this is 115, I just need to find this. Because I want to find the whole bearing.
How do you know this one?
Alternate.
Oh, okay.
Yes. What is the height here? Pasi, calculate this one. What is it? Skylar, you smile at the screen so fondly. You love math. Okay, thank you. What is the answer? You can just... So you see boys very scary these days, right? Look at you, tell lies, then they still can laugh like that. Okay, what? 49.5 meters 3 SF. Okay, so if you don't believe, let's say I just randomly do this, right? Let's say this is 5. HA. I want to find A, right? Then I cosine 45. A over H. Isn't A 5 cosine 45? So if I have H, I want to find O, I will use sine. So O over H is 5. So you cross multiply. Isn't this 5 sine 45? So as long as you have hypotenuse, you can get the base by using 5 cosine of the angle. Yes, this is the shortcut. Then you don't have to do this and cross multiply. You straight away know the base and the height. You need to be faster in A math, so the shortcut will work in A math better, but use that for your E. Part B is here.
Is there MCQ for O level?
No MCQ for O level. I have. Your chemistry and physics paper 1. E math don't have. A math also don't have. Don't have already. There goes your MCQ for math in primary school. Yes. Oh, that's how you tell me zoom in, is it? Because zoom is like that. Not like that. I cannot understand you. This is fun, don't know for which world one. Your same dimension, right? There, same dimension.
Messy?
Yes.
Rush, just back it up. Rush, you're a whacker.
Okay. So your angle of elevation and depression is always the acute one. So, okay, I have 2 person asking me this already. So you're saying that I want to look at T, right? Why is it that I must look here? Why I cannot look from here, leh? Then I turn backward until I see T. Okay, but usually we look like that, right? To that point. We wouldn't want to look until behind like that. So turn your body and look like that. So find me the acute, don't find me the obtuse. Okay, if you want to find the other way, can, but go and find the acute for me. Okay, so the angle of elevation and depression, yes, I should just point out that it should be acute. Okay, 4 minutes. Sine rule is for yes. So after you find this, you get the obtuse one, right? The acute one, right? Straight away is this one. Because sine will give you two answers, one acute, one obtuse. So if this one is the obtuse one, then they give you the acute, then you are actually finding the next one. Yeah.
Right now, or like
Yes.
Can you only do it if the length is hypotenuse?
If the hypotenuse is not given again, must have hypotenuse, yes.
How do you look the angle of elevation from here?
From B, so I'm here looking like that. Then I look up until I see T. So this is how much I look up. From eye level, I turn until I see T. So this one.
Oh, okay. So for 8.1, how do we know where to locate the end, the north?
When they say bearing, then your diagram sure got N.
Example, which one?
You see, when your diagram got N, straight away must have bearing question part A or not. Then,
So R is...
then you turn until you hit the point you want.
Oh, okay. So I repeat.
Can. What are you doing? Who is on the floor? If they give the angle here, then this is 58 cosine of this angle, and this is 8 sine of the angle. Yeah, so you follow the angle. See, poor Kale, he just wanted some fresh air. Okay, 12:40 already. Resume. Yes, 4 minutes is up. 4 minutes is up. Okay, ready? Ready? Okay, find AB. What rule should I use? Cosine rule. So, AB square is sum of squares of the other two sides minus 2 times the product of these two lengths followed by cosine 105. And then I take square root. Shh. Come back. So 3SF. Okay, always give me the 5SF first, then the 3SF. So calculate. Okay, what's the value? Don't need to copy anything, Ravan. You got copy anything from just now until now or not? 47.663. So it's 47.7 meters. Okay, and then when you copy here, copy the 5SF. Okay, next is I want area of triangle. All you need is the half AB sine C. So go and look for the V where the two sides and the included angle are given to you. So A part 2, area is just half AB sine of the angle between them. Yes.
In the exam, will that be like A part 1, 1, 2, 1, 2,
Yes.
4?
Yes. Yeah. Your trigo question is like that. Very elaborate one. Okay. So what is the area?
Area is
400 and
Like large questions like this in the exam, right?
400.
won't lah. 432 point.
73, 4, 7, 7.
Okay, so it's 433
Yeah.
meter square. Okay. So next is I want to find the shortest distance from C to AB. Shortest distance means perpendicular distance. So how do you recommend I do this? I already know the area of triangle is 432.73.
You can find CA to the.
So let this be X. Let this be X. Is there a quick way that I can get the area? Okay, so actually it's half times the base, which is 47.663, times the height. I don't know what is it. The shortest distance is the height. And then it's 432.73. So to find the shortest distance, I just divide the whole thing over. Okay, alternatively, if you don't want to do it this way, you could also form a right angle triangle. And then, let's say you know, but you don't have the angle. So you cannot. Then you have to find the angle, then you go and find the height also can.
You can use nodding and then at 62 goes to the top. Because
C from A 62. No, I don't know the angle though. So may not be. The alternate is it? Can.
then 62 goes to the top.
So what Raj is saying that there's an alternate here. But this perpendicular may not be parallel to the North Pole. So I cannot assume. So may not be able to do that. Okay, so what's the answer for shortest distance? 1579. So 18.2 meters. 3SF. Okay, so they ask you anything, you have an answer to it. It is what you have learned before. Okay, last one is bearing of C from B. So I'm going to replicate the North Pole. And then I turn from north all the way until I hit C. So this is the bearing I want to find. So imagine that I form another North Pole here. So all these are going to be parallel. Right? So this is 62. Tells me that this portion here is 62. Alternate, right? Then this will tell me that this angle here is 43. Okay? And then I will know that this angle here, I don't have. I have. This is 43. So can you find the bearing? 180?
Oh shit, wait, no, I have 360 minus 5.
Okay. So the bearing of C from B is just 360 minus the 43. So 3179. 27. Okay? So you can split it this way. Okay, the last one is the angle of elevation and depression. How can you actually
Don't you make your own triangle?
yeah, so if a bird is flying vertically on top of point C, so bird, okay, so flying vertically on top of point C, and the angle of elevation of the bird from A. So I'm going to look up all the way to the bird. They are saying that this angle of elevation here is 20 degrees. So this is the vertical height of the bird. So this is a right angle triangle. So as long as you can visualize the right angle triangle, then you can find the height, the distance of the bird from A. So they want you to find this. So part B, if we redraw the vertical triangle, okay, this is where your bird is. I don't know what is this distance, but I do know that at the bottom here is 32 meters. This is 20 degrees. Yes.
How do you know it's perpendicular?
Because if something is vertically above, it is always perpendicular to the floor. So you will always see that it's 90 degrees to whatever base you have. So the bird on top of this, right? Wherever you are looking from the other side, let's say I look from here, right? It will always be a right angle triangle wherever my bird is. Okay? So that triangle that you have will always be a right angle triangle because this is vertically above. So anything vertical to the ground is 90 degrees. Okay? Yes. Yes, you can use sine rule. If you want to use sine rule, then you need this angle.
Just 180 minus 90 minus
So this one is 70. So you can I don't know, I just call this distance lah, huh? So distance over sine 90.
Wait, Miss Wong,
Yes.
how is it 90 degrees?
Because anything that is vertical to the flat ground is perpendicular. Because they say the bird is hovering vertically above point C. So it must be 90 degrees. You cannot be standing vertical but like that, right? Vertical means like that.
The drawing doesn't look 90 degrees. Yeah.
No, so you must visualize that is standing out of your paper.
The line is slanted.
That means what I'm drawing now, right? I'm drawing now is the triangle is flat here. Right, this is my triangle. So if the bird is perpendicular to it, I'm perpendicular to it. If I'm looking up from here, it's a right angle triangle.
VRC. Then the bird.
Okay, you can see from the table. Yes, it's 3D. So now my triangle is flat on the paper, right? Yes, the triangle is on the floor, on the ground. So I'm the bird. No, the bird is on top of my head, right? And then that person on the floor is looking up at my head. So can you see the right angle triangle?
So the triangle is
Yeah, like that, like that.
So that one is not going north but it's going upwards.
Yes. Not north, it's not like on the paper. It is upward. Outside of the paper like that. Yeah.
I use the biggest
This person, Okay, sine 70.
Is it okay we do it the other way? Like,
You want to use Tuakaso also can.
no, like sine 70 over 32.
Can. Just that you need to manipulate a bit more. Okay, what's the answer? What's the answer?
27.20.
So 27.2. 11? Huh? What's the answer?
I got 27.
on 34.
Huh?
I got 27.
34.05 something. So 34.1 meter. 3SF. Okay? So actually, we are almost done with the chapter. If you look at the next page, right? I only have two 3D shapes. And in the 3D shapes, as long as you can see the right angle triangle that they are talking about, you have mastered this chapter. So, next lesson, right, if I can, I bring that two 3D shape inside for you to see the right angle triangle. Then we are done with the chapter. So proud of you. Okay, so tomorrow, all the sides are 13 by 13. Okay? Then they want to find the length of the diagonal QS. So take note, this triangle, because it's a square base, although they draw it like a parallelogram, you know it's a square. So this is a right angle triangle. So to find QS, just by Pythagoras theorem. So by PT.
Are you doing a quiz today?
No?
Oh yeah.
Let's finish it. Left two example only. I thought mine as well.
Challenge one is it just Pythagoras?
Yes. Very simple ones only. Okay, then you end up having square root 338, which is 18.385, 18.4. Okay, so finding QS is not a problem. It is just Pythagoras theorem. The only kind of issues you may have is you forget there is a right angle triangle. Okay, next one, VSQ. So if we look at this triangle, okay, the green one, if you want to find one of the angle here, okay, what you can do is you can use whatever property you can. So what do you think you will use to find this? We do know that VO is 10, this one. So again, if you look at the pink triangle I have here, right? If you drop a triangle at the bottom, from the middle line in the middle, that triangle is always a right angle triangle. Okay? So if the middle line that we have, which is the VO that you see there, any triangle they form with the vertex is always a right angle triangle. So I just need you to be able to visualize that. So this triangle that we have here that is standing, let me color in yellow. This one is a right angle triangle.
Did you make the triangle yourself?
I think over the years they cut and yeah. Yes. Okay, any more homework, just put it on my desk. Okay, so that yellow triangle will help me find that angle over there. So if I zoom into this triangle, VOS, I want to find this. I have this being 10. I can find OS by dividing this length by 2. Okay, can you see that QS is the entire length, but OS is at the midpoint. So this is the midpoint, yes.
But we have to write the drawing for it. Is that just for our understanding?
For your understanding, you don't need to draw it out. Memorizing timetable. Okay, so once you have these two, you can find the angle. So HAO, I have O and A, I will use tangent. So tangent of the angle VSO is 10 over this. So just take a tangent inverse. So there's nothing new that is taught here. It's just you being able to see the right angle triangle. If you can see, you can do. So answer is 47.4096. Okay, since VSQ and VSO is essentially the same angle, you can just give me this. Okay, last part, how to find volume of pyramid. You all learn in lower sec. 1/3 volume of pyramid. What? 1/3? What? Times base area times height, the vertical height. So base area here is just your square. Your vertical height is the 10, and then you are done. So all these are just add-on questions that feeds on your lower sec topic. Yes. Can. Okay, I remember when in lower sec, y'all are, yes. SRQ is a right angle triangle because it's a square. So it will always be a right angle triangle. Yes. Yeah, so when they draw it like a parallelogram. But when you see it, you must see it as a square.
Wait, it's because like all the diagonals, like the angles will be right angle inside.
Yes. So as long as you can see the right angle in the 3D shape, then this subtopic is easy. Okay, it's a square base pyramid. If I never remember wrongly, when you were in lower sec, you were asked to find total surface area. You were asked to open up the shape, and then you have the net, okay, of this square base pyramid. And then you were asked to find the slant height by using Pythagoras theorem. So if you can still remember, this was the slant height that you have found by using Pythagoras theorem, right? Once you have the slant height, you can find the area of the 4 pieces of triangle. And then with the square, you can find total surface area. This is your lower sec work. Okay, volume and total surface area.
Is there other geometry
Cylinder is given on the front page. Other than pyramid, any kind of prism is also 1/3 pi r square, 1/3 base area times height. So no other extra one if I can remember. Cause sphere is also on the first page. Will I test what? Sphere is on the first page, so that one you don't have to worry. Okay, another shape that you had was a rectangular base pyramid. So just take note that the 2 triangles, they are opposing each other are equal. If you can still remember. And then you were asked to find 2 different slant height using Pythagoras theorem 2 times. So if you can remember, there was another slant height that you need to find. This one, the blue one. If it's a rectangular base. So these 2 and these 2. So rectangular base, the 2 triangles at the opposite sides are the same. So you have to find it this way. I'm just recapping. This one is sec 1 or sec 2's work. Okay, but now you are finding height, you are finding angle and so on. Yes. Do we need to? For this example, no. But if I add in a question total surface area, then you need lah. Yeah. Okay. So this is the one type of shape that you can see. The other type is the one behind. Sometimes they give you a cuboid also, which is the one I brought. Yeah. All done? Not yet. Yeah, but I just want you all to see the side. like the sandwich box like that. I couldn't remove this. Okay? Can? Not yet? Yeah, tangent. Because O over A. Yeah, you need to be able to visualize the right angle triangle inside. Okay, so no matter where you shift this red side, okay, I cannot shift now. But this piece, any side you choose, it will be this same right angle triangle. Because it's a square base. So whether it's this triangle, this triangle, this triangle, all the four of them are exactly the same. Congruent, This pink triangle, okay, is congruent, all four of them. Okay, next at the first. Here, 338. But it's not a nice number. One is this, the sandwich box. Okay, this shape, can you all still remember the word prism? What does it mean? When you all learn prism, what does it mean? When I say triangular prism, what does it mean? The cross-section area is uniform. Means if I cut this in parallel to these two triangles, any part should always give me that same triangle. This shape is like a stack of triangular cuts. Any slice you take out will be exactly the same as the two at the ends. So that's a prism. So how to find volume of prism? You just find the area of the cross-section area. Yes. Then you multiply by the height. Okay, if you need the volume. The height is the distance between the two parallel sides. So this is the formula for volume of prisms. Okay, same like cylinder. Just that cylinder, the two parallel sides are circles. So it's pi r square h. Okay. So this one is recap of your lower sec work. Not that it's relevant here, but just recap. Okay, I want to find AC. AC falls on the rectangular base below. So although it looks like a parallelogram again, it is essentially a right angle triangle at the bottom. So at the bottom, it's a right angle rectangle. So any triangle formed at the bottom, it's a right angle triangle. Okay, so here, let me redraw my ACB. So this is 24. What else did they tell me? BC is 10. They never write on the diagram. Okay, very sneaky, but please fill it in. Yes. So to find this, just Pythagoras theorem. So the math behind it is not difficult. You just need to see the right angle triangle. So by PT, 24, no, AC is square root 24 square plus 10 square. Is it a nice answer? Or 26. Okay, so this length is 26.
13 square plus 13 square equals 1 square.
13 square equals 13 square. Yeah. Yeah, I square root already. Why I put as what? AF? No, oh, I put at the wrong place. Okay, can. This one, sorry. 26 is here. Okay? Then next, I want to find AE. So I want you all to see that this triangle that I have here. Okay, I'm going to draw the triangle that they want. So let me use red color. This is the triangle they want me to draw. Okay, this triangle, This triangle that you see, is it a right angle triangle? Yes, right? It's standing inside your sandwich box. So this is a right angle triangle. So if you know that the base is 26, the height is 7, can you find what is AE? So again, it's another Pythagoras theorem. So it's just a lot of right angle triangle for you to deal with. Just now we found AC, right?
The base is AC.
Yeah. Okay, so with that we can find AE. So it's 26 square plus 7 square square root. Is it a nice number? No, right? Okay, 725. So answer is 26.926. So you can leave it as 26.9. Okay, so you either use the exact one for the next part if required, or you use the 5SF. Don't use the one you rounded off. Okay, next. Okay, now that I know this, I will write it down as 725. Okay, next question wants me to find DAF. Yes. Your calculator is wrong.
On my calculator, I got 57. And not on my thing, AI gave me 912.
How can?
Calculator?
I mean, this is what.
Okay, so part C, I want to find this triangle, the yellow one here. So I want DAF. So part C, let me draw that triangle out. F, D, and A. I know AD is 10. AD is 10, right? The opposite sides are the same. DF is 7. So to find DAF, I will do a HAO. So tangent. So do a tangent inverse. 7/10. So 35.0, 1 dp. Okay? This is the yellow one. Okay, then the last part, we will go back to the triangle that we drew just now. This one. Okay, this same triangle. I have all three sides, so I can find any angle easily. So this blue triangle that we drew just now, for part D, now they want me to find what is CAE. This angle here. So just have to draw that out. The blue triangle. Okay, you are strongly recommended to use the values they give you rather than the ones you calculate, unless, in case you make careless mistakes. So HAO, so again it's a tangent. Tangent CAE. So inverse. Okay, of course you can use cosine, you can use sine. Just make sure the square root 725 is correct.
So you just put it at square root.
Yes. So this is 15.068, so 15.1. Okay?
What's the difference from all of these three?
Degree is the one we are learning now. Radian is another measurement of angle, which we will learn in the next chapter. Yeah, gradient we don't learn. At JC or Poly that you learn. Yes. What? Pi is 180 degree. Yes. What? Degree? Or angle? Okay? Can ah?